Hi everyone, I hope you're okay, and I really hope that guys the videos we keep uploading are helping you out. This is the 30th video guys, which simply means I'm doing question 30. Please do expect a total number of 33 questions. Um, yeah, let's just get right into it. The flow diagram below shows how an alkane can be used, or how an alkene rather can be used to prepare other organic compounds. Letters A to G represent different organic reactions. Okay, this is our alkene over there. Uh, okay, let's just get into questions. Write down the type of reaction represented by A. We are moving from an alkene, which is prop 1 in, to form a propane. That means we were dealing with addition reaction. Addition reaction, right? And the type of addition reaction is called hydrogenation. Okay. For reaction B, we are moving from propane to form compound Y. But what is compound Y? Remember that, guys, initially compound Y was formed by using this propene over there. Compound Y, our compound Y would be a chloroethane. Are you together? So if I want to move from propane to form this chloroethane over there, that means I must perform a substitution reaction. Substitution reaction. And then reaction E. Reaction E, I'm moving from an alcohol to form a propene over there. That means that was elimination. Let me draw the structures of the propane, compound Y, the major products here and the major products there. Compound Y, guys, would have been that one over there. Compound Y, let me draw it here. That would have been 2-chloropropane. H. That's a Cl, né? And then that means since you're forming this haloalkane by using an alcohol according to reaction G, that means we had a secondary alcohol and its structural formula was just like this with the hydrogens all around. Okay, and then compound X, we are adding hydrogen bromide we are adding it on our propene, so we'll end up having a bromopropane, 2-bromopropane. And then lapayana, we have propane. Okay, these are the 4 compounds which were formed. Okay, let me re-answer these questions. For me to move from this for me to move from propane to form propane according to reaction A, we can see that I have 2 extra hydrogens over there. That means I've added hydrogens. Are you together? And then for me to move from a propane to compound Y, these 2 have substituted one another. That's why I'm having a substitution reaction. And then for reaction E, whenever I move from alcohol to propene, that means I would have eliminated these 2 over there. Are you together? And the type of elimination would have been dehydration. dehydration. Okay, and then I must write down the IUPAC name of compound X. Compound X is just 2-bromopropane. And then for reaction D, I must write down the type of elimination reaction. I'm moving from compound X. This is my compound X. I'm going back to propene. That means I must eliminate these two. I'm eliminating a hydrogen and a halogen. So this would have been it would have been dehydrohalogenation. Eh? This would have been dehydrohalogenation. Are you together? And the two conditions for reaction D. For dehydrohalogenation, guys, what is the time? Ne? You will need a concentrated strong base. Your strong base can be this one or potassium hydroxide or lithium hydroxide. Ne? Any of these three, and they should be in ethanol. They should be inside ethanol. Ne? Firstly, that's you need any of the three bases inside ethanol, as well as heat for you to for the performance of dehydrohalogenation. Excuse me. And then 4.4, I must write down the formula of an inorganic reactant needed for reaction F. What's reaction F? I can't see F over here, guys. Oh, there's reaction F. I'm moving from compound X to form an alcohol. Compound X is a haloalkane, right? So the inorganic reactant which is needed is a dilute strong base. I'm performing hydrolysis. Whenever I move from haloalkane to an alcohol, I will always perform hydrolysis. Are you together? And the type of inorganic reactant needed, I need to have a dilute strong base. It can be either one of these or it can be one of these. And please note that, guys, they have to be dilute. They have to be dilute, guys. Ne? Please remember that. They have to be dilute. Okay. And then I must write the balance equation for the hydrolysis reaction. I had compound X, which had bromine lapayana. Okay, let's write it there. And the hydrogens plus NaOH, which is dilute, and I only need mild heat. And then what will happen is that the only difference over here, guys, will be the bromine and the OH. So these two will just switch places. I'll simply have an OH over there and the Br over there. Are you together? So the structural formula will be like this. That's how, guys, we're supposed to tackle this question over there. Please, guys, before you answer, start by analyzing your flow diagram first and then answer the questions. Thank you for your time.